Hey there, we're going to learn a little bit faster way to simplify these nth roots. So instead of expanding everything, we're going to learn how we can take the power that's under the radical and divide it by the index, and that will help us figure out how many to remove from under the radical and how many to keep under. So let's think about what we were doing when we expanded and then grouped our factors to the size of the index. Really what we were doing was we were dividing. We were dividing the power under the radicand by the index. And then whole groups, you could think of this as even groups or whole groups, were removed, moved out in front, and that corresponds to the quotient of our ratio. And then anything that was left over, or anything that had fewer than the index, that had to stay under the radical. That's the remainder, okay? So let's look at a couple examples. Well, maybe we'll just do one. Let me change my pen here. All right, so if I looked at the fourth root of x to the ninth, okay, I could write x 9 times and group them in 4s, right? Or I could go 9 divided by 4 is equal to 2 with a remainder of 1. Okay, so this is the number that I bring out in front, so that would be x squared. And then the 1 is the number that stays under. So that would be x squared times the fourth root of x, okay? So we're going to take our power, we're going to divide it by our index. The quotient is what we pull out in front, okay? And then the remainder is what stays underneath, okay? So let's try this. I'm going to prime factor 72, and when I do that, I get 6 and 6 and a 2. So I have plus or minus the square root of 2 times 6 squared times x to the 8th. Okay, so look, this power here on the 2 is less than my index. My index is a 2. So that just is going to stay there. This x6 squared, I'm going to divide by 2. Squared divided, power divided by index. And then my x to the 8th, I'm going to divide that 8 divided by 2, power divided by index. So I get plus or minus, the quotient of 2 divided by 2 is 1, so that's 6 to the first. And then I have 8 divided by 2, that's 4. So x to the fourth. And then I have underneath my radical my 2. From here, this stayed. Okay? So I have 6 x to the fourth square root of 2. Right? I'm going to prime factor my 16. I'm finding a fourth root, so I'm looking for groups of 4. So if you remember, this is 2 to the fourth. So I have the opposite of the fourth root of 2 to the fourth x to the ninth. Okay, we've kind of looked at this a little bit. So I still have my negative out in front, and I'm going to go power divided by index. So how many of these am I taking out? I'm going to take out 1. And then I have x to the 9 divided by 4. What's 9 divided by 4? Well, that's 2. So I'm going to take out an x squared. And how many are going to stay underneath? I have a remainder of 1. So the fourth root of x. Okay? I want you to try these and for your video questions, and then come back and see how you did. All right, I'm taking the square root of 16, so that's 4 squared, x to the 8th. So this is 4 to the 2 over 2, x to the 8 over 2. So this means I get to pull out 1 4, so I get plus or minus 4. X, 8 divided by 2, that's an even divide. So that's x to the 4th, and there's my final answer. Number 2, I'm going to take q cubed minus 5 to the 4 over 3. So how many groups of 3 do I get to pull out? 1. How many do I have left over? Well, if you divide 4 by 3, you get 1 with the remainder of 1. So that means that a q cubed minus 5 has to stay under the radical. Okay. Number 3, we're taking the 4th root of a negative. Can we do that? Nope. No real solution. It's because of the negative under the radical sign. And now I'm going to do number 4 here. And I'm going to take 243 and I'm going to prime factor it. And we get, what is it? This is 81. And I'm going to prime factor, keep going. And that gives me 27 and 3 and 9 and 3 and 3. So I get 1, 2, 3, 4, 5 threes. Well, that's good because it matches my index. Yippee! Yippee-i-yo-ki-yay. So this is 3 to the 5th, a to the 10th, b to the 15th. So now I'm going to divide my power divided by my index. 5 over 5. A to the 10 over 5. B to the 15 over 5. Okay. And all of these are even divides. So this is just a 1, so I get 3 to the 1st. A squared. B cubed. And there is my simplified answer. All right, just like that. Okay, so there's a rule that we have to think about, and this only deals with when we have even indexes, and it's called the even, odd rule, okay? So when you have a real expression, and you have an even power under the radical, and you have an even index, and say you divide them and you get the quotient produces an odd exponent. Okay, so if you have 2 divided by 2 is 1, so you have an even, sorry, you hear my phone going off. 2 divided by 2 is equal to 1. You have an even power divided by an even exponent, and you get an odd result. Okay? What you have to do is you have to put that in absolute value. That's to protect it from going negative when we don't want to. It doesn't matter when you have an even situation, because if you plugged in a negative, raising it to an even power would change it to positive. So in this particular case, if we have x to the 12 divided by 4, we're going to get x cubed, even, odd. So we have to put that in absolute value. Here I have x to the 6 divided by 4. So this one's kind of a little bit convoluted. Think about it. You have, this is like 4 to the 4 over 4 and 2 over 4. So this would be the absolute value of x, and then we would still have the 4th root of x squared. So this part right here, because it's a 1 and then a remainder of 2, this 1 has to come out with absolute value bars around it, and that stays under the radical. So let's try and do a couple of these. Okay, 64, I'm going to prime factor it, and I get 2 and 32. This is going to end up to be all 2's. So I get negative 6th root of 2 to the 6th, x to the 6th. Now I'm going to, instead of expanding everything, I'm going to divide my power by my index. I have that negative out there. Then I have 2 to the 6 over 6, x to the 6 over 6, okay? So this negative does not, you don't worry about that with the even, odd rule, okay? That negative is still out there, okay? And then 2 to the 1st, do we ever have to worry about that going negative? No, so that doesn't need absolute value. Then I have an even power divided by an even index, and I get an odd result, an odd quotient. So that means I have to put that in absolute value bars, okay? All right, why don't you try these and then come back and take a peek. All right, plus or minus, so I have to have a plus or minus in my answer. This is 7 squared x to the 14th. So this is plus or minus 7 to the 2 over 2, x to the 14 over 2. So I don't have to worry about a 7 going negative, so this is plus or minus 7. And then I have an even power divided by an even index, and I get an odd exponent, so I have to put that in absolute value. This is 2 to the 4th. This is 2 to the 4th. This is x cubed minus 3 to the 12th. So I have a negative out in front, and 2 to the 4 over 4. And then I have x cubed minus 3 to the 12 over 4. Okay, still have my negative. Then I have a 2. I don't have to worry about this 2 going negative, all right? And then I have x cubed minus 3 cubed. When I take 12 divided by 4, that gives me an exponent of 3. And so I have to put this in absolute value bars. All right, and then I have 81, and I'm taking the 8th root of that. So 81 is 3 to the 4th, and then I have x to the 24th. Ooh. Y to the 8th. Notice how I have fewer than 8, so I can't take any of those out, so you might as well just leave that be. And then I have x to the 24th over 8, y to the 8 over 8, okay? And then I have an even and an even, and then I get an x cubed, all right? So I know I need absolute value bars. and then I have an even and an even, and I get an odd, y to the first, and then I have the 8th root of 81, or 3 to the 4th, whichever way you want to write it. Okay? All right, and the 6th root of 64, a to the 18, b to the 24. Well, 64 is 2 to the 6th, so I have the 6th root of 2 to the 6th, a to the 18th, b to the 24th. So this is the equivalent of 2 to the 6 divided by 6, a to the 18 divided by 6, b to the 24 divided by 6. So this 2, I never have to worry about it going negative because it's positive. A to the 18 divided by 6, that's 18, that's even over even, and I get an odd, so I know that has to go in absolute value. And b is even, but I get an even answer, so I don't have to put that in absolute value. So here is that answer. This is just, you can read this. This just kind of tells you what to expect when you have even roots and when you have odd roots in dealing with different types of radicands. So feel free to read that. Ask me any questions if you need to in class tomorrow. And then we're going to actually have 2 days of assignment on this. So tomorrow we're going to do what's on page 31, and then the next day we'll do what's on page 32. Thanks for listening.